Okay, so we are going to start tonight looking at Module 2, which is going to be vector analysis. As we look at Module 2 learning plan, you're going to notice that we are going to be working in Chapter 3. So yes, we're kind of going out of order here. We did Chapter 1 and Chapter 4 in Module 1. Now we're going to be kind of scooching back a little bit, and we are going to be doing Chapter 3. So the PowerPoint presentation is here. And you're going to notice that the sections that I have in there is not every section in the book. So I strategically want you to make sure that we're only going to focus on the things that, that I have outlined there. And we have some examples to go through. I'm going to scooch back one. You're going to notice that we have, oopsie, I'm in the wrong module. I went down too far. We have a sessions recording. So anything down below the line is going to be past course recording. So from last year. And then I will add our recording or our lecture that we do this evening to the top once it's complete. And then additionally, you're going to see that there's practice problems and an assignment number 2 for Module 2. As we look at our practice problems, you're going to notice that these are the examples from the chapter that we're going to be going over. We will be using AutoCAD for these. I want you to get that experience of going through and doing those and then handing them in. There's also a couple of things that I want you to just fill in, you know, as part of the practice problems, kind of reviewing what you learned, but then also what you feel like you need some extra practice on. And we'll talk about the requirements and the formatting as we do our, as we do our lecture this evening. So, then we've got assignment number 2. Assignment number 2 is going to be the list of at the end of chapter problems here. And again, we won't be ready for these until we you know, get done with the lecture. So we'll discuss those later this evening. And just as a reminder, the calendar has the due date for these 2 items at the end of the day on Friday. I know it's kind of quick, but we're in an 8-week format. It's kind of what we have to do to make sure we stay on track with the rest of the modules. So I'm pushing you a little bit in the beginning here. So let's go to our learning plan and pull up our PowerPoint presentation. So I'm going to pull this up. Now, again, for those who maybe came in late, we are going to be using AutoCAD. So if you want to open up your AutoCAD, open up your start file, we will be doing some examples using that information. So chapter 3 is vectors. So as we start out chapter 3 here, you're going to notice that the chapter talks about 2 different popular quantities that we come across in engineering, and that is going to be scalar quantities and vector quantities. So on this page here, we kind of talk about the differences between the 2. So a scalar quantity is going to be a quantity that is sufficiently, if you are fully defined, as we say, by simply stating its magnitude. So for instance, if I just want to know how long something is or what a distance might be, I would just identify, oh, that's 8 feet long, or it's 25 miles away. Temperature is a scalar quantity. So 78 degrees would be a fully defined quantity for temperature. And then time also, it's only going to be, for instance, 50 minutes. When we cross over into talking about things that are vector quantities, okay, a vector quantity needs 2 things to fully define it: magnitude and direction. So magnitude is going to be, for instance, if I'm looking at velocity. If I'm looking at velocity, I say, oh, I'm going 25 miles per hour north. 25 miles per hour is the magnitude by itself. That would be a scalar quantity. But once we add the direction going north, now we became a vector quantity. I'm sure in other courses that you've had, like physics, you've talked about that. We also talked about it in statics when you guys had statics with me. So, so scalar and vector quantities. And in this chapter, we're focusing on vectors. So if we go to figure 3.1 in our book, that is at the bottom of the first page here in the chapter 3, page 43. The figure I'm referring to here is this one right here. So we represent a vector with a line and an arrowhead. It has to have an arrowhead to be a vector. Lines are just, a line by itself is not a vector. So when you're handing things in for me, you have to have arrowheads on all of your vectors. And all the problems we're doing have vectors, okay? You'll notice that the length 1.5 units. Now, units could be units of velocity, so miles per hour, feet per minute, inches per second, whatever it might be. It could be acceleration is another vector quantity. So that would be feet per second squared, okay, for instance. Or it could be force. It could be something that has a magnitude of 25 pounds, 30 kips. What would be another one? Newtons. So we could do 10 newtons could be the units, okay? And the units are always going to be whatever the magnitude is going to be the length of the vector, okay? Now, direction is going to be signified by two things here. Number one, you'll notice that there's an angle 30 degrees from horizontal. That's part of the direction. The other part of the direction is the arrowhead, because if we don't have an arrowhead, we wouldn't know, okay, it's a line at 30 degrees, but is it going up and to the right or is it going down and to the left? We have to have the arrowheads, okay? So, so when we're creating these vector diagrams, arrowheads, labels, and then fully defined for direction if an angle is appropriate, okay? Oopsie, wrong one. Now, vector analysis graphically, we are only going to be focusing on graphical analysis, just like we did in the previous chapter. So you are going to be drawing your vectors to scale. We're going to be using AutoCAD to do that. And again, the length of the vector is going to be its magnitude. The angle and arrowhead, I wish I would have added that in here, is going to fully define its direction. Now, the CAD skills that you need in order to do proper vector analysis are the things that we've been using up until this point, but a couple extras here. So you're going to have to know how to draw lines at a specified length and an angle, insert lines perpendicular to existing lines, extend existing lines, trim them, draw arcs, locate the intersection, possibly of two arcs or two lines, measure the length and add a dimension to existing lines, and then also measuring angles as well. Now, the first part, and we're going to be scooching over to section 3.8. Previous to 3.8, between 3.5 and 3.8, they're doing analytical solutions, meaning that they're using trig to, find your answers. Again, I default to just graphical and kinematics because you get a lot of that in other courses. So I think it's a nice time to just show, like, look at, we can get the graphical solution here. And then we also get the benefit. Some of you may think of it as a benefit, some may not, but you get to use AutoCAD again. It's good to have that refresher because AutoCAD is going to give us nice, accurate results when we're looking for our answers. Now, when we do graphical vector addition, we are going to be using what we call the tip-to-tail method. The tip-to-tail method is when we add two or more vectors, we are going to be taking the tail of the first vector and putting it at our origin. The tip is then going to point outward from that origin. And then we're going to add the next vector by placing its tail on the tip of that already placed vector. And then we continue to do that for however many vectors we have, called the tip-to-tail method. Now, once we have all of our vectors in place, then we can figure out the combined effect of the vectors, called the resultant. For those who have had me, and most of you had for statics, we did a lot of resultant work, okay? We solved using the rectangular coordinate method. That's an analytical method using trig to get our resultants. But in this case, again, we're going to be focusing on the graphical. So we'll be showing that process. Now, when we have vectors that we're going to be determining what their net effect is going to be or their combined effect is going to be, that resultant is going to be equal to the addition of any of the vectors that are present. So we're going to find that you are going to have a series of vectors, usually identified with letters of the alphabet, A, B, C, D, and so on. And then your resultant is either going to be called out as an R for resultant or a J. We're going to find that the book uses that variable as well. We're going to be writing a vector equation. Just like an algebraic equation, a vector equation is going to have an equal sign and two sides. You'll notice in the case of this vector equation right here, R, which is our resultant, which would be the combined effect of the vectors, is going to be equal to the vectors that we're interested in. So we're going to have vector A plus vector B plus vector C. Now, you're going to notice that the operator in between each one of these variables, which represent a vector, is not the same as the algebraic type of operator. Normally, if we were adding algebraically, we would simply have A plus B plus C plus blah, 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 however many more. Why do we have that greater than sign there? Any ideas based on your experience, previous experience? I'll open up the chat box too if anybody wants to answer this. It is a vector symbol. And why would we want to put the vector symbol in here, meaning a vector addition as opposed to an algebraic addition? Why would we want to do that for vectors? Correct, because the vector has both magnitude and direction, right? So if I would take the magnitudes of each one of these, they would never add up to the net effect because we're going at an angle. Unless the vectors are all along the same line of action, horizontally or vertically, we cannot add them algebraically. You remember that from statics, okay? And that's why we would break things into components so that we could get as much as possible on the x-axis horizontally, as much on the y-axis, and then that way we could just look at which way are you pointing and assign a convention to that, okay? And we could then add those algebraically. But in this case, graphically, we can't. So our equation has to reflect that, and adding the greater than sign after the operator now says I'm adding vectorially, not algebraically, okay? So we're going to be adding these equations and making sure we have them, we understand what they mean. The other thing that I want to point out on these, on this equation at the bottom here, so resultant is equal to the combined effect of A, B, and C. Notice that the next one is CBA. What I want to stress here, and the purpose of this is to let you know that no matter what the order that you add these vectors in, they will always remain the same resultant. So if you're, for instance, comparing results with a classmate, and you look at the problem and they added it in a different order than you, look to the resultant and make sure that you both did it correctly if your resultant is the same, okay? So one order isn't necessarily better than another order of the vectors because you're still going to try to find that net effect or that combined effect on the point where the vectors are applied. So let's look at example 3.5. Okay, example 3.5 is found on page 49 in your book. I'm going to zoom out here. Okay, and it's, I don't know, a third of the way down or so. So this is example problem 3.5. We will be using AutoCAD to solve this. So if you wanted to open up AutoCAD, you can. But it's asking us to graphically determine the combined effect of the velocity vectors A and B. That means we want to find the resultant. So finding the combined effect means we want to find the one force that we could use to replace the two individual forces or the two individual velocity vectors that are here and have the same net effect. So first things first, we're going to draw to scale each one of those vectors in AutoCAD. And I'm going to do it along with you here. So I'm going to kind of put this on the side here. We're going to open up AutoCAD. I have my start file open right here. I am going to do a file, save as, and I am going to save this as example 3_5. Okay, save closer. Okay. And this is my start file that we've been using. Now, in this case, you're going to notice we aren't going to be drawing kinematic diagrams for this chapter right now. So we're gonna put that on the back burner for a little bit. Don't worry, we're not going to completely abandon it. They'll be coming up again. But for right now, we're going to be drawing vectors. I want my start file because when I look at my layers here, it offers me a couple different options for my object line. So I have my regular object line for white, and then I have object 2, which is going to be my green dashed lines. So you're going to notice that what I do for the work that we do for these examples is I'm always going to use the individual vectors. I'm going to put on the object layer, and then I'm going to do my resultant, whatever it is, R or J, is going to be on the object 2. And then any dimensions that I add or any of the call outs variable wise for any of the vectors are going to be on the notes layer. Okay. So that's why I have that up here. So we are going to really not be using a whole lot of what's here. We'll use a little bit of the text, but other than that, we'll be generating everything using just the line command and such. So the first one that we have is going to be 59 inches per second. We're not going to be adding the units to our drawings, okay? Just because, I don't know. Yes, units are important. I'm not saying that they're not, but for the purpose of doing vector analysis, we'll know what the final units are. So we're just going to be drawing the vectors as is. So I'm going to zoom out here a little bit because it's going to be 59 inches long. So I'm going to do the line command. I'm going to click on line. I'm going to left click where I want my line to start. Now, I currently have my ortho on, so I'm going to take that off. And what I'm going to do is I'm going to point this up and to the right. Okay. Now, I'm going to put my 59 in, but I'm not going to hit enter. I'm going to hit tab because I need to be 59. And when I hit tab, you know, it's might be hard to see because this is bigger than what it's supposed to be. But the tab is going to tab to the angle dimension that I can put in. So I'm going to put in 59 and I'm going to hit tab. And then I'm going to put in 30, enter. And now I'm going to do a zoom extents. And here is the line that I just created. Okay, it's pretty big compared to my frame member and my slider, which is okay. All right, so 59, tab 30. Now, as you know, we have to signify where our arrowhead is going to be. Now, you might think, oh, well, why don't we just use like a leader line and then put the arrowhead on? That's nice, but then we've got to mess around with the scale and all that kind of stuff. And if you recall, these are not like official drawings that we're going to release. They're for, you know, calculations and layout purposes. So instead, all we're going to do to show our arrowhead is we are going to do the line command. I'm going to go to the endpoint here, and I am just going to show a very crude 2 lines that are going to signify my arrow. That's it. I want to keep it simple for you guys. Okay. So that's how we're going to show our arrow. Now, as far as the label, all I want to do is I want to add the label A to this vector. So you know that you already have an A down here. So I'm simply going to move A from there, I'm going to zoom back out, and I'm going to put it right about there. So it's little. Now, what I need to do is I need to scale this large enough so that I can see it when I do my screenshots later on, okay? So to do that, how I like to do it is I'm going to use the scale function, and I'm going to select my letter, okay? Once I have it selected, I'm going to hit enter, watch your command line, and now it asks me to specify my base points. I'm going to go kind of right in the middle here of it, and all I'm going to do is I'm going to move my line out until I feel like it's large enough for that vector, and right about there seems large enough. Okay, and then I'm going to left click and it's going to be that big. Okay, now I'm going to draw my B. Okay, so B is going to be a line. This one is going to be going up and to the left. Okay, and that's going to be 30 units long. Don't hit enter. Now hit tab. Now notice that in this case, our angle is coming from 0 degrees. So, so if I look at the vector that I want to create here, B, from 0, it would be 90 plus 30, right? So it would actually be 120 degrees. So you want to pay attention to that. I'm going to go back over here. So now I hit tab. I want this to be 120 and then hit enter. So now it drew it going up and to the left, and there's my line. I want to add my arrowhead. So 2 simple lines at the end here. There we go. Doesn't have to be perfection. All right. And then I'm just going to copy my A. And I'm going to move it over here. And this one is going to be B, C, capital B. All right. I can get rid of the other symbols down here, so I will. So I just have my A and my B. And it's worth doing a quick save. Okay. All right. So we have these two drawn. Okay. Now, the next thing that we're going to do is we are going to identify our vector equations. So we're going to take A plus B is going to be equal to the resultant. So we're going to simply, I'm going to copy either A or B. I'm just going to put it above here. All right. And then I'm going to edit that. And it's going to be R is equal to A and then plus greater than sign for plus vectorially B. Okay. Every one of your vector diagrams needs a vector equation so that you can tell me what's the order that you added these in. Now, when I look at the equation here, it's an equation with an equal sign. It has a left and a right side, okay? I know everything about the right side, right? I know A, I know its magnitude, I know its direction, I know B, magnitude and direction. So I'm going to start on the right side of my equation. Now, the equal sign, I like to say, is my origin of my vector diagram. So if I'm starting out here on the left-hand side, or I'm sorry, on the right-hand side of my equal sign, that means that I'm starting at the origin with vector A. So the origin is going to be at the tail of my first vector. So I need to draw little crosshairs there. So I'm going to add a couple lines that are large enough that when I do my screenshot, I am going to be able to identify that, oh, this was the starting point for the equation. Okay. If you don't make it big enough and I can't see it on your screenshot and you say to me, no, it was there, I just couldn't see it, it's wrong. Okay. I need to see it because I need to verify that the equation that you wrote was the diagram that you did. Okay. And that tells me where the equal sign is the origin. Now, because I have my A as my first variable, I'm going to add B to it. So using the tip to tail method, I'm going to take the tail of B and I'm going to place it at the tip of A, which was the previous vector. So I'm going to move this vector, put a box around it, enter. My base position is going to be its tail, and I'm going to place it at the endpoint or the tip of A. Now I'm going to move my vector equation. I'm going to move it down here just so it's not in the way. So now what I've done is I've done the right-hand side of my equation. So I've added A plus vectorially B. Okay. Now I've exhausted everything on the right-hand side of the equation. I am going to go back to the other side of the equation. Now I can solve for R. So to solve for R, I always say when I cross back over my equal sign, I got to go back to the origin. Now, because I'm going to be drawing my resultant in place, I'm going to change my layer to object 2. And I'm going to draw the line from the origin to the endpoint of the last vector in my equation. In this case, it's the tip of B. Okay. Now, yes, we're not going to see the dotted lines. That's not really a big concern of mine. I'm more concerned about that it's a different color. Okay. Now I'm going to draw my arrowhead. So as we look at our vector equation, it says that the resultant R equals A plus B. So that means that this R, if I replace A and B, this is the one force that will have the same net effect on, if you would, that point or that origin. So that means that my arrowhead is always going to be pointing at the very last vector that I created, the tip of that last vector. So I'm going to add my arrowhead to the upper right-hand side of that vector. Okay. Now I'm going to move my A to the outside here, and then I'm going to copy A, and I'm going to rename this and label this as R, my resultant. Okay. Doesn't hurt to do a quick save. R a little bit lower. Okay. Any questions so far? All right. Now, the answer that we're trying to get here is what is the magnitude and direction of the resultant? Notice I did not add the magnitude and direction dimensions for A and B. I only added the label. The reason is you can imagine it's going to get really cluttered and full of dimensions. And really what we're looking for in as far as an answer is going to be what is the resultant's magnitude and direction? So those are the only two that you have to add your dimensions for, whatever it's asking for. So we are going to grab, oopsie, don't do the, I'm going to put it on the notes layer first. And then I'm going to do an angular dimension. Now the angular dimension, if you're not listening to me, come back to me, please. The angular dimension has to come from a vertical or a horizontal axis. Do not put it in reference to another vector, okay? You're going to have an answer key for your assignment. I am always measuring from 0 degrees, like standard 0 degrees, okay, from that horizontal, just so that you know. So I am going to use my horizontal origin line and the angle for the resultant. And then I'm going to go in between here. Now, I place that dimension and you'll notice that I can't see it. It's too small. So I need to go into annotation, dimension style, modify, and fit, the fit tab, okay? And right here, lower right-hand side-ish, we're going to change the scale. And we're going to change it to, I'm going to start with 75 because it's really small. Set as current, and then I'm going to hit close. Oh, that was really big. So let me just go back in, annotate, dimension style manager. We'll do another modify. Should still remember where your fit tab was. And let's do, what do you think? 15 worked out? Oh, okay, 15. We'll do okay, set as current and close. Okay, yeah, 15 looks good. So it has to be something that's going to be relatively close in size so that when you do your screenshot, I can see it. If it's too small and I can't see it, then you won't get credit for your answer, okay? Because when you do the screenshot, it doesn't remain in vector mode here as far as the graphics. It blurs out, it gets grainy as I zoom in. And so if I can't read it, I'm sorry, I can't give you any points or any credit for it. So make sure that it's large enough in order to be able to see it. So there's my angle. And then the other dimension I need to add is going to be an align dimension to see how long my vector is. So I'm going to do an align dimension. I'm going to go from the endpoint to the endpoint of that vector, and then right about there. Okay. So label for each one of them, but then I need the magnitude and direction of whatever you're solving for. In this case, it's the resultant, okay? So let's do a quick file save. And then you're also going to want to add, so I'll copy this text up here. This is example 3, 5. There we go. That way, when you do them, you have then the labels. So you would take the screenshot then here. Now let's check our answer to what the example answer was. So if I go to page 49 towards the bottom here, this is their, if you would, screenshot of how they worked it in AutoCAD. Now, first of all, you're going to notice that they identified for us their origin. Okay, I have to see that. So you have to add an origin required for every one of these problems. If you don't add an origin, that's points off. Okay. The second thing you're going to notice that they identified their vector equations. They did it in 2 ways. I'll talk about the second way here, but the first way that we did it is on the left-hand side. Now they labeled each one of their vectors and they added the arrowheads. They didn't put the arrowheads at the endpoints. That's okay. They just did it along the line so you knew which way it was going in each case. So both of them are valid ways of showing it. If you like this better, go ahead. Sometimes it gets a little crowded at the endpoint, so it's not a bad idea to do it this way, but that's how they're doing it. It's still similar. But we added actual dimensions on the actual on the resultant. I don't want to see a label for the resultant. I want to actually see that you dimensioned it because that tells me that you got it. Also hold it out a couple decimal places, at least 3. You're going to see I always have 4. Okay. Then they did add the angles for those other 2 vectors. I don't want those on. Those clutter things up, and I just want to focus on what is your final answer, the resultant, magnitude, direction. Okay. Now, on the right-hand side, all that they did was they changed the order of the vectors that they added. So in this case, they started with B and then added A. So notice that they started at their origin. They started with B going up and to the left. And then at the tip of B, they added the tail of A, then going up and to the right. Notice that we get the same resultant, both angle and magnitude, or direction and magnitude. Okay. So again, it's just kind of proving that point. I'm not going to have you guys do it in that other order. You can see that it works out here. Okay. So questions on that first example. Making sure that you have the items that we see here and that everything is large enough when you take your screenshot that I can read it. Okay. Doesn't hurt to do a quick save. All right. And we'll go back to our PowerPoint. So that's our first example problem. The next example that we're going to do is going to be example 3.6. So let's go underneath. We're going to turn the page, and the very next example is at the top of page 50. We want to graphically determine the effect of the force vectors A, B, C, and D. So we're going to take these 4 vectors. We are going to add them tip to tail and find out what the net result is, or what the resultant is of those 4 forces. So first things first, we have to go ahead and draw each of our separate vectors here. And then we're going to label each, and then we're going to do the work of adding them together. So I'm going to go back to AutoCAD. I'm going to open my start file again. I'm going to put them on separate files. I know people like to ask, can I do it in the same file? I don't care. That's fine if you do. If you find that to be helpful, go ahead. But just know that when you do your screenshots, you have to be able to read the values. And sometimes when you have different things that are at a very different scales, it doesn't always, it's not as intuitive as you would think. Oopsie, I want to do open, talking and trying to do something at the same time. And I wanted to, here's my start file. I like starting over fresh and then just adjusting as I need to. And I'm going to do a save as right away. This is going to be example 3_6. There we go. Okay. And I'm going to start by showing my object line here, or putting my object layer on. I'm going to zoom way out because I know this one, my values are 200. So it's going to be a pretty long line. So I'm going to show 200 vertical line. Kind of zoom out here. I'm going to go line, and I'll go here, go straight up 200. And there it is. So this is my first line. Okay. And this is going to be my A. Turn my ortho off. Okay. I'm going to grab the letter A down here. So I'm going to move A. It is small, but then I'm going to place it next to, and then I'm going to scale it. One was found. Yeah, it's tiny. Okay. Oh, there it went. I'm going to start there, and then I'm going to move it back. I kind of lost track of it where it was. Okay. Scale it again. And then I'm going to start in the middle and about that big. That looks good. So that's my A. Then I'm going to do B. B is going to be 226, but now this one is at an angle, so I have to hit tab. And notice that our angle is coming from standard 0. So this one is at a 15-degree angle from 180. So 180 minus 15 I think that's 165, is that right? From 0? Does that sound right? 165, is that right? There we go. Oh, and then I can just continue with my arrow on that one side and then line and on this side. There we go. And then I'm going to copy A to label B. There we go. Okay, so I've got A and B. The next one is going to be C. This is going to be 176. Let's see, 176 tab, and this is 45 degrees. There we go. Here's my arrowhead for that one. That one. Copy to get C. And then my last one is going to be D. And I'll put that one here. This is going to be 300 tab and then 20 degrees. Oh, 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 oh. And label this one D. Okay, and I'm going to do a quick save. I'll give you a chance to catch up. I'm just going to stop sharing. Okay, is everybody here and ready to do our vector addition? Okay, anybody still finishing up the individuals? Okay. All right, so now once you have these in place, now we're ready to do the vector addition or to find the resultant of those two, those four forces. So if we look underneath here, we are going, oopsie, this side right here. Sorry. I'm going to scooch down here. This is their screenshot. Now, they did it again in two ways. You don't have to do the problems in two ways. We're just going to do it in one. We are going to add them in alphabetical order for the top equation. They did it in another version where they did it in a different order. And really the point here again is that our resultants are going to come out the same. We're just going to do the one on the left. We'll do A plus B plus C plus D, and then find the resultant and make sure that our answer ends up what they have here. So I'm going to go back to AutoCAD. Since I'm starting with A at my origin, or as my first vector, actually, before I start moving those around, why don't I put for reference on the screen here so I don't have to just talk it through. Let's put our vector equation. So it's going to be R is equal to A plus greater than signs plus vectorially B plus vectorially C plus vectorially D. Okay. So that means since A is the first vector to the right of my equal sign, I need to place it at the origin. So we want to add the lines so that we can see that crosshairs for the origin, and I know exactly where you started, and it's going to match where the equal sign is for your equation that you write. You have to write the equation for your vector diagram. So A, and then to A, I'm going to add B. So I'm going to move vector B, and from its tail, I'm going to place that tail at the tip of the previous vector, vector A. Okay. Then I'm going to add C. So I'm going to move C. its tail is going to go at the tip of B. And I'm going to move its label to the outside here. Okay, yeah. Then I'm going to do the same thing for D. I'm going to move D, its tail, to the tip of C. So now as we look here, I have added all the vectors on the right-hand side of the equal sign. So now I'm going to cross back over the equal sign and I'm going to draw the resultant in. So since I crossed over the equal sign, that means I'm starting back over at the origin. I'm going to change my layer to object 2. I'm going to add a line. I'm going to start at the origin. See, scooch in here. There we go. And then we're going to go to the end point of the last vector. Now I'm going to add the arrowheads to my resultant. The arrowheads are always going to be at the tip of the side where the tip of the other side of the equation is. So in this case, at the tip of D, D to the outside. Yeah. And then I'm going to label my resultant by copying one of those variables. And then now I'm going to change to my notes layer and I'm going to add an aligned dimension. It's very small. So I'm going to go to annotation, dimension style manager, modify, fit tab. And this one, I think I'm going to put at 75. We're going to see how that looks. I think this one's close. There we go. Could even be a little bit bigger, but I think that'll be fine. And then the other dimension I need to add is going to be the angle. So I'll arrow down, do an angle dimension from horizontal on that origin to our vector. And I have 69 degrees. I think I'm going to make these a little bit larger. I'm going to go back to modify, fit. I'm going to change this to 90 times. Set as current and close. Yeah, that's better. Now, the dimensions can cross in this case, but don't cross over the values themselves, okay? And then maneuver around or move around your vector equation. I think I'm going to put it at the top here. And then also make sure that you add a label for the example 3.6. There. Oh, it's tiny. Forgot I should do a copy of the text that I already have sized. That works. And we'll do a edit then. There we go. That's easier than trying to figure out what scale it should be. So now let's compare our answer back to the example in the book. So if we go underneath here, you're going to notice that they have the resultant is equal to 521. Remember, we are not showing it as a node as they see here. We are showing it as an actual dimension. So I know that it's drawn to the right number. And if we look back, ours is 520.7. So that would round up to 521. And then angle wise, I have 69 here. If I go back, they have 68. I got 69 the last time I did it earlier today. So I'm certain I'm right. I'm very confident in my numbers. So so off by just a little bit, I'm not too concerned. But if your value's off, like in terms of 5, even 3, 5, 10, that's too much. Okay. But if it's within a degree, we're good. We're good. All right. So any questions? This would be what you are submitting for example 3.6 as part of your practice problems for module 2. Okay, I'm going to do a quick save here. And then we're going to go back to our PowerPoint. Does anybody need this up yet to look at it? Make sure you have everything. Okay. Not seeing anything in the chat. All right. Okay, back to our PowerPoint. So, so we are going to look now at vector subtraction. So vector addition was probably familiar to you because like I said, you've probably seen it. I know you've seen it in statics and also you've seen it in physics, but we don't see vector subtractions all that often, but we are going to encounter them in some modules that are coming up. So it's important that we know and understand how to do it. So vector subtraction is basically going to be when we subtract a vector, we're just going to reverse the direction by 180 degrees, and then we're going to add it tip to tail like we normally do. So in essence, what we are doing when we have a resultant is equal to, in this case, vector A minus vector B. What it really means is that we're going to add the negative version of the vector to the other vector. All right, so let's kind of see what this means. So I'm going to go underneath and we are going to skip over to a couple sections here to page 55, okay? Now, as we look at figure 320, if we want to determine or we want to draw a vector and in its negative form, all we're gonna do is we're gonna change the arrowhead to be on the opposite side of the line of that vector. So if we have a positive going up and to the right, a negative or negative A is simply gonna be 180 degrees from what it originally was. So I'm going to take the vector from up and going to the right. I'm going to be putting it down and going to the left, but the label changes now to negative A. Okay. Now, remember what I said earlier. If I can subtract a vector off by adding the negative value. Okay. And this is why this is important. So we're going to look down here. In figure 321, we have two vectors, A and B. We're going to take A minus B, okay? So that means that we're going to show the negative version of B. Notice that it is going down and to the left from its up and to the right. Its up and to the right was positive for B. Now down and to the left is negative, so it's called negative B. Now what we're going to do to add those two together or to subtract B from A, we're going to add the negative version of B, okay? So over here in part C here, here's our origin. We're going to take A minus B or plus the minus version of B. So now notice that we're going to add B. We're going to put its tail in its negative version at the tip of A, and then its tip is going to go here. Okay, so we're taking the negative B and we're adding it to A. So instead of saying A minus B, we're saying A plus negative B. Same thing, just like in algebra. And then our resultant is going to start back at the origin and it's going to point to that last arrowhead. Okay, so what I like about this method is that we still are actively using tip to tail, which is the same process that we used for addition. The only thing is that when we see that there's a negative or we're subtracting a vector, we're instead going to add the negative version of that vector. Okay. Now, that's how we're going to continue to do it. The book does it another way, and it kind of flips between these two. So I like to be consistent. So I'm going to show you the other way, but then I want you to forget it, and we're going to do it this way. Okay. But I want you to understand that when you look at these examples in the book, why they're doing what they're doing. So in this case, on the right-hand side, you'll notice that our origin is right here. We're going to put A in position. So this is going to be A minus B. But instead of adding the negative version of A, we're going to take the positive version of B. And instead of going tip to tail, we're going to go tip to tip. And then go back to the origin, and J is going to go to the tail of B. So yes, we end up getting the same answer, but it's kind of like it's opposite world here. I like knowing one set of rules or one process and then just maybe applying a little bit different. That's why I like adding the negative version, because we're still tip to tail, but we're just going to change the direction, and then it's just like we normally do it. Okay, so that is going to be how we're going to be doing vector subtraction. Okay, but again, if we compare our answers in the examples to what the book does, you're going to notice that they kind of favor the second version, which I'm like, get the same thing, but you got to think a little bit more. And I like not thinking. Okay. So the next example we're going to do is we are going to do example 310. And it says here, we want to determine the resultant by subtracting velocity vector B from A. So this one is going to be J, which is going to be the representation of our resultant, is going to be equal to A minus vectorially B. Okay. So first things first, we are going to create these vectors in our file in their positive form, and then we'll deal with the subtraction and we'll talk that through. So I'm going to go over to AutoCAD. I am going to grab a new start file, and then I'm going to rename it right away. And this is going to be example, see, 3_10. Okay, save. And then now what I'm going to do is I'm going to simply create those two vectors in their positive form. I'm not going to talk this through. I'm going to let you do yours on the side as well. So I'm just going to kind of do it here, and we'll meet up in a couple minutes when we've got them in place. I want this for my arrowheads bigger. I'm going to go ahead and I'm going to identify my vector equation right away. So J is equal to A minus vectorially B. Okay. So I'll wait a minute or so for you to get yours all set. Okay. So the vector equation that we're going to do here is we are going to do J is equal to A minus B. Okay. Now I'm going to redraw that. I'm going to like add this to this, but I'm going to say it's also equal to A plus vectorially, and I'm going to put in parentheses here, negative B. Okay. So the reason I'm doing that is we are going to change the direction of B so that it's going to be the negative version of it. Okay. So right now in its positive version, it is going down and to the left. So we're simply going to erase those arrowheads. We're going to change B to negative B, and we're going to put our arrowheads in the opposite side or the opposite direction. So the negative version of B is going to be up and to the right. Okay. And so make sure that you change the label and the direction. And now we're going to add tip to tail the negative version of B to A. So as I get started with A, I'm going to have to add my origin. So I'm going to add a crosshairs here at A. Again, large enough, but not, you know, crazy big. Okay. And then I'm going to move my negative B. Its tail is going to go to the tip of A. And I'm going to move this on this side. So any questions so far? Okay. So now that I have A and B positioned here, I am now going to change to my object 2 layer. I'm going to add my line from the origin to the endpoint of B. And that's going to be my resultant J. Its arrowheads are going to be at where it meets with the tip of B. And then I am going to label this J this time, okay, because they're using the variable J for this resultant. And then we are going to change to our notes layer. I'm going to get my angle from horizontal. Okay. It's pretty small. So we'll see what we have here. I'm going to try modify. This time I'm going to try maybe 50. Okay. Set current, close. Oh, that's pretty good. I'm okay with that. Maybe a little big, but I'm okay. So I got 99 degrees. And then I'm going to do my aligned dimension, endpoint to endpoint. And I've got 57.61. Okay. So then, just to see how I did, I'm going to turn the page and do so good. I got the 99. They got 56.8. So just curious what you guys got. You got 56.8? Oh, let me see. Oh, look at that. I can see I am not on my endpoint. That's why. Oh, I know, right? There we go. 56.8. Now I've got it. Good, good, good. Okay. And then at 99 degrees. Yeah, I think I saw when I did it a perpendicularity, but I'm like, I bet you got it anyway, but it didn't. Okay. And then you want to add your designation for, example. Oh, no, I don't want to do that. I'm going to do this copy. Otherwise, I got to set the scale again. So this is example 3.10. Okay. So make sure you have the example designation. Make sure that you have your vector equation. Make sure you have each one of your vectors labeled, especially the B with the negative, okay? Because that's the negative direction. That's not the positive. And then that you have the J, the resultant's magnitude, and its direction identified by the angle and the arrowhead. Okay, any questions? This would be your screenshot. For example, 310. Who needs, oops, Jack got, yeah, you got the 56.7. That's okay. That's all right. I have to believe you're right there. Chris Hole got 56.8. Perfect. So any questions on labels or what's required on our example problems here, which will translate also to the homework problems that you're going to do? Okay. All right. So do a save on that one. And then let's see what we got coming up. So we did vector subtraction. We did the example 310. Oh, we got another example, 311. Perfect. Okay, let's go underneath. 311 is at the bottom of page 56. So first things first, we have 4 vectors to draw. And then we are going to be determining J to be A minus B minus C plus D. So go ahead and get your positive versions of each one all set. And then we will discuss how to finish this up. So I'm going to do an open on start file. Go. Okay. How many are still working on getting their vectors in place? Okay, I'll give you a little bit more time. No problem. No problem. I'm going to add the equation as well, as long as I'm here. So you're going to want to do that. Okay, are we ready to start putting it together? Okay, so at the bottom here, I put our vector equation. So as stated in the problem, we're taking A minus B minus C plus D. But I rewrote it. I did another equal sign, and we're going to do it as A plus vectorially the negative version of B, plus vectorially the negative version of C, plus vectorially D. So that means that we're going to add them all tip to tail, but we need to change B and C. So we're going to take the arrowhead off of B, going up and to the right. We're going to change this to negative B. And we're going to put our arrowheads then for that one going down and to the left for B. Okay, so this is the negative version of B. Then we're going to do that very same thing to C. We're going to get rid of the current arrowheads. We're going to change this to a negative in front of C. And then we're going to add the new arrowheads going up and to the left, because this is the negative version of vector C. Okay. Now I'm going to add them just like I normally do. Okay. So since A is my first vector, I'm going to add an origin symbol to its left-hand side here. So I'm going to grab and I'm going to put an origin. And again, just so it looks like a crosshair, so I know exactly where you are starting your vector addition, so I can make sure they're in the right order, right orientation. And then what we're going to do is to the tip of A, I'm going to add the tail of B. So I'm going to move B's tail to the tip of A. Then I'm going to move C's tail to the tip of B. And then I'm going to move D's tail to the tip of the negative C. Okay. So again, the process of adding them is the same tip to tail, but we're just changing the directions of the ones that are the subtractions or the negative versions of. So far, everybody follow? Any questions? All right. And now we're going to add our J. So we're going to change our layer to object 2. I'm going to add a line from the origin to the endpoint. And then we're going to add in our arrowheads. Okay. B to the other side here. And then I'm going to label my resultant. Now this time the resultant in this case is J. So make sure you call out the correct label. Sometimes it's R, sometimes it's J. Yeah, I'm gonna say yes, because just pay attention to what it's saying in the problem, because it'll say J is equal to or R is equal to. Yeah. Okay. And then now we want to change our layer to notes, add an aligned dimension for the length. Ooh, it's really tiny. So we're going to go into annotation, dimension, style manager, modify. I'm going to do 85. Set current, close. Oh, perfect. That looks really good. And then I'm going to do my angle dimension from horizontal to J. Bring that out here. There we go. I did 85 this time. Yeah, you'll just have to play with it. I know it's not a great answer, but just kind of the nature of it. Example 3.11. There we go. Now let's take a peek in the example 11. What did they get? They got 365 for J and 81 for their angle. Perfect. Perfect. Now this angle happens to come from A, but A is on the horizontal axis. So we always go from either the horizontal or the vertical axis. Okay. All right. Do a file save. We're good to go. Okay, vector addition and subtraction. Any questions at the moment? All right. We're going to take a break here, okay? Because we're about, I don't know, we're about halfway through. We've got a couple more examples to finish, but I want to give you guys a break. So we will pick up where we left off here when we get back.